Hey guys, in this video I'm going to continue making parts for the Z-axis of the mill. What I'm trying to do today is to machine a pocket for a big ball bearing. It's about 2 1/3 inches in diameter. Here it is, and it will go on top. Basically, the ball nut or the ball screw for the Z-axis is going to go right through here. The place where it's gonna have to fit is 4 by 5 and some inches plate, about half an inch thick, that I have on the mill right now. I've already done some work, drilled and tapped on the top here for the motor support, motor mount support. Drilled and tapped on the side. And this one is going to anchor it to the spacers that will go inside the column of the mill. Will actually go right inside here and get screwed on the side to hold it all together. But today I'm machining the hole for this big ball bearing, and the way we're going to do it is we're going to utilize the CNC capability, the 2D CNC capability, I should say, of the mill. Keep our fingers crossed. Hopefully everything goes alright. So I'll turn the camera around, show you a little bit the setup, and then we're gonna get to cutting.
Right, here we are at the CAD program, and this is the whole mount for the Z-axis. The plate I'm trying to work on is this plate right here, and this is the ball screw that goes up and down, and the big bearing is gonna go in this space right here where there's nothing right there, that big space. So that's where the big bearing is gonna go underneath this, and it's gonna be, I don't think it's gonna be quite press fit, but it's gonna fit really tightly, hopefully, right in that plate. Those holes that you saw earlier are for, in the back of the plate, are for the motor mount right here, and that was already being finished. Let's see if I can get it in the shot here. That's the motor with the little pulley, and that's gonna go back and forth, and there will be a pulley that goes from here to the ball nut that's gonna be sitting right up here. Let's see. Next, we're gonna go to our CNC controller. I have used a wizard. Let's see the last wizard that I used here. Alright, so let's see if it's in the shop here. Alright, this is the wizard that I used. I basically gave him coordinates for the center of the pocket, and I gave it the pocket diameter. I actually used a caliper to measure the ball bearing outer race, which is a little bit slightly different than what I had in the plans. I'm going to be running at 20 inches per minute. The tool diameter I'm using is actually going to be a 2 flute. This is a 4 flute, but I'll use a 2 flute, 0.4375 inches. I forget what that is, 5/8, something like that. I don't know, maybe 5/16. Don't remember, but it's 4.375, and we're gonna go down to 250 thousandths, and every time that I go down, I'm gonna go down to 25 thousandths at a time. So we're gonna cut circular slices into this plate, about 25 thousandths thick each. Hopefully 20 feet rate is not too fast to break anything. We might have to slow it down if things don't work out right. Up here on the side, you can see this is the zero of the machine. This is where the coordinates of the pocket are. If you can actually see it, let's try holding it. And you might be able to see, let's see, there you go. You might be able to see a little bit all the circular cuts there. There you go. It's going to get in the center and go around and cut. And I modified the G code so that it'll stop at the very end of every pass, So it gives me a chance to, let me exit here. It's gonna give me a chance to lower the z-axis manually, and see if I edit the G code, make it bigger. So you can see this is one circular cut, and then it's gonna have a repositioning part. I put an M1 optional manual command to stop the mill so that I can lower it manually, and we're gonna have about 10 of these cutting circles. You can see the depth of this one is 75,000. The depth of the next one is gonna be 100,000, so on and so forth until we get down to 250,000. Let's close these up, and I think we're ready to go. I'm gonna find a good position for this camera, and I'll be using the vacuum because I'm anticipating that this is gonna make a lot of chips, and so it's gonna be a little bit noisy, but I'll put some music or something and I'll try to speed it up. Alright, so we're gonna go on and do it right now. Alright, so let's start this thing. Alright, let's keep our fingers crossed, and we're gonna launch it. I'll try without the vacuum here for a sec. Take a look at it for a minute. Oh, it's actually pretty smooth. Alright, it looked kind of as though it was a little rougher, but it's pretty smooth. So I think I'm gonna try without a vacuum for the next pass. Let's go down to 50,000. Dial it in. 40, 50. Alright, let's see how that works.
see. How it turned out. Well, the finish is actually really nice. Better than I was expecting. Of course, there's another hole that we're going to have to cut there later, but so far so good. Let's take a quick look and see how this fits. Oh, this is a perfect fit. Well, it's as good as bad as than I was hoping for. So I'll say this is a win-win situation. We used our 2D mill to fabricate parts for the third axis, and it's working. I guess all that time we spent setting up and correcting for proper backlash, and that's really paying off right now. And we set it up and cut the center hole, and this part will be done soon. Hey guys, so what do you think? I think it turned out pretty darn good. I was hoping for something like that, but I wasn't really expecting it to be as good as it turned out to be. Unfortunately, my camera was, my iPhone's battery was dying, so I finished the rest of it off camera, and I have it here on the table for final assembly. And so I'll turn the camera around and let you see what it ended up being like. So here's the top plate mounted to the rest of the pieces. I have a couple of things back there just to hold it up because it's a little bit lopsided with the weight. But it's pretty much completed, at least this part of the Z-axis. And all we have to do is just to put that in. As I promised, this part is adjustable. Can hardly do it on with one hand. Let me put this camera down. See. There you go. This part is adjustable, so you can change the tension of the belt that is going to be going from this pulley to the other pulley that is going to be up here. And all we have to do is put this bearing in. And you'll see that there's a nice tight fit. And that's it. It's probably seated and able to spin. So I'd say all in all, things are turning out really well. So guys, this concludes this part of the build. This is the part that will attach to the top of the column once again. It's completely done, finished and functional. And the only one thing we're gonna have to do is mount a flange up on top and a flange on the bottom, the ball nut and the actual bowl screw, and we'll be able to put it on the mill and give it a go. So thank you for watching. I hope you enjoyed it so far. Stay tuned, more to come. Bye.